Okay, so today's lesson is dedicated to some, new discoveries when you create your DLL file that you want to use in Microsoft Excel, or that you want to use in C#. Firstly, I'll talk a bit about how to build up your DLL and which so-called calling convention to use, because it really matters which one you use. And secondly, I like to talk about a little bit about how you can speed up your C++ code, how you can optimize it, okay, without actually touching the code. It's just some settings in the project. Okay, so let me start by creating new DLL. So go to your Visual Studio, start with C++, Windows console application, and I'll call it temp. Hit next. Use empty project. You can uncheck this, or you should uncheck this if this option is available. And here, just make sure you have console application. We are not going to check DLL right now. Okay, finish. And here we are going to add new file. We can name it main as a main file, and as usual we start by integer main, no arguments, and return 0. And into this area we are going to type the code of the function. To make things simple, I'm just going to use a very trivial function called square, which, as it is clear from the name, it just returns square of any number you put in. So the output data type is double, the function is called square, and it only takes one argument, any variable x, and it returns x ton x, which is x square. Okay, so let me just test the function. Say double result is equal to square of, say, 10, and let's see what numbers we're gonna have. So you can see it's 100, which is 10 squared. This is correct. And now we are going to export this function as a DLL. Okay, so in order to export this function, you have to use some keywords in this area. Okay, and however, there are several ways what the keywords should be according to what you want to get. Okay, so let me just open this prepared Excel sheet where I have some notes about so-called calling convention. If you want to export a function as a DLL, you have to put here a calling convention. It's something that tells the application and the system how the function shall be called. It has something to do with memory and also naming of the function. Okay, so let me just explain in example. You have these two standard you have these two basic calling convention. There is also one which is called fast call, but I'm not putting it here. This calling convention is normally assumed by C++ or Visual Studio. Okay, if you investigate the properties of the project, I'm not sure where exactly it is because it's actually not important in the settings. There we go. Calling convention. You get this one, okay, as by default. Then you can choose std call or fast call. And what this convention does, it actually influences the function name, and it also influences it also depends which one you use, so that you can really call it from your Excel or VBA or maybe C#. Okay, so if you use this native one, you won't be able to call it from VBA. Okay, however, if you use this one, you will be able to call it from VBA, but it has some, there are some points that also matter, and the most important one is that if you use this std call, it will change actually the name of the function. I will show you shortly what will happen with the name. Okay, so let me just put here into our code some keywords for export. In order to export your function, you must use this keyword. This basically tells the compiler that this function is about to be exported. Okay, and put here std call. Maybe I have to switch this one. Now it works. Okay, and if we compile that, nothing really happens. It just works fine. And now we are going to change the properties of the project so that it is built as DLL. Okay, now it's built as application. So let's change it to DLL. Apply. Okay, and if you build it right now, you'll have this DLL. Okay, so copy the path of the DLL, and let's test the function within Excel. Okay, so in here I just put Rx, and let's go to Visual Studio. VBA Studio. Add a new module, and here you have to write declare function lib as library. Now comes the path of the DLL, and now it matters what arguments you pass into the function. Okay, so in our example we were passing double. Okay, so x as double, and the output is also double. Okay, and the library will be called square. This is should be like this. We are basically saying declare function square, which is implemented in this library. okay, and it takes one argument, which is double, and it returns double. But you must put some more code in here, because if you used only this x as double, it wouldn't work. You have to use by val, which tells VBA that x is passed by value, not by reference. Okay. Okay, so now this should work. Okay. So let me save this file, and let's call, here we're gonna have x squared, and let's call square. Now let's see if it works. No. And the reason is that even though we named the function in the same way as in the C++ Studio, its actual name is different. Okay, and this is what is meant by decoration. So in order to discover what's the true name of the function, you have to use some third-party application, and I'm using dependency walker, which is sufficient, which is free and sufficient for this purpose. And let's go to the path where the DLL is stored, and you can see that actually from our function, this is the real name of the function. Okay, so if we use this function name in here, it will give us our desired value. So you can see that this is really ugly. Okay, I'm gonna copy the function name and here put alias. Okay, so this is a keyword. This alias is a keyword that tells the VBA that we are looking for a function which is called like that in the DLL file, and within VBA it will show up as square. Okay, now you can see that it really works. So this is something about the function decoration. Okay, you can see that it somehow, well, distorts the name if you use the std call. Okay, it's caused by the std call. Well, how this expression here, or the function name, decorated function name, is built, well, it's based on some algorithm, but you can see it's not easy to figure out what's the what this name shall be. Okay, and for this reason you can use extern_c before the function declaration, and extern_c ensures that this complicated looking function name will simplify so that you can actually estimate what's the function name. Okay, the function name will be always function name. If you use this extern_c in combination with std call, the function name will be always like this, function name and at, and now comes number of bits in the memory, okay, of the argument. So if we are using double, it takes 8 bits in memory. If we had 2 arguments, both of them were double, you would have to have 16. Okay, and I will show you the logic in a moment. Okay, so let's use extern.c. We already have it here. I will close this one so that it can enter the DLL file, and I shall also close this file because it's also using the DLL. Okay, so let me close. I don't want to close the Excel. Okay, it should be fine. And let me compile it once again. Build solution, and we have a new DLL. Okay, let's go to our file, and now let's see what happened. Now we expect the function name to be square at 8. Okay, so it follows on this principle where we have a prefix, which is the underscore, then the function name, then at, and a number of bits of the argument. Okay, so double takes 8 bits. If it were I don't know, integer, it would be less than 8 bits. I don't know the exact number right now, but let's see. Oh, what happened? There we go. So you can see that now we have really this name, and so if we want to call the function, we just type in underscore square at 8. Okay, and if we use, say, 20, I'm thinking about the problem right now. What might be wrong? Square. So another try. There we go. It works. Okay, so keep in mind that if you use this extern.c with in combination with std call, you got slightly simplified decorated name. Okay. Well, what if you wanted to use this cd ECL, you would get no decoration. That would mean that the function name here is what you would be calling in VBA, so you wouldn't need actually this, and you will be perfectly fine with this function name. But the problem is that this calling convention doesn't work with VBA. Okay, I guess it works with C#. I'm not sure, I would have to verify, but I'm almost sure it works with C#, but it doesn't work with VBA. Okay, so we will have to stick with this std call because it's compatible with VBA. However, if you don't want to use these ugly looking names, you can easily go around this decorated names. Okay, the key thing is that you use so-called def file. Okay, def file is a file that somehow defines the function within C++, and I'm gonna add this definition file. I'm just wondering where it is hidden. I know it's here, module definition file. If you don't have this file, you can create a file in, say, Notepad, and you put extension .def, and you can just add existing item, and you include the def file created in Notepad in here. Okay, so I can do it so that you can see. Notepad. Oh my god. And here you have to write library. Now you have to come up with some name of the library. I'll use temp, such as the name of the solution here. Temp exports. And now you type in the name of the function, okay? Square. So you can do it as simple as I do, and let's go to documents, project, temp, and def file def, or definitions, doesn't really matter. Okay, now we're going to add the file. Wow, what's wrong? Okay, let's see. And next thing you have to do is to change something within the properties here. You have to go to linker, input, and refer to the module definition file. Definitions def. Okay. Now you can. Now the things simplifies it substantially, because you can delete all of this and you just keep this std call. Okay. Build solution. We cannot enter the DLL because it's open. So save it, close it, and let's build it once again. Cannot open file definitions def. It's probably because it's open. What's bad? So let me take this away, remove it. No. And let's edit normally. Def cpp and it's called properties defs. Build it. Now it works. Okay, so I didn't really have to edit as the def file. It was only sufficient. It was sufficient just to use, say, template for CPP file and rename it to def. However, you can, if you have this say premium version or professional version of Visual Studio, it's somewhere over here that you can directly use the def file from here. Oh, okay, that's it. Okay, so now we have this library prepared, and what you if you run it now, it won't work. Okay, I just refresh the sheet and you can see it returns value error. And what you should do is that you erase this, because now the function name is really just square. Okay, and this is ensured by the definition file. Okay, so let's save it. And we could also investigate the behavior of CD ECL, but we won't use it because it doesn't work with VBA. More specifically, it allows VBA to enter the function, but it does not allow to return a function value from that function. Okay. We can also use the dependency walker. Close it, open it once again, and we can see that the function name, when we use the definition file, is really just square. Okay. The next thing I wanted to show you is how you can import the DLL in C#. So let's create some C# project. C# console application. Okay. In order to import a DLL, you must use system runtime and interrupt services. Okay, this will allow you to import the DLL file. In C#, you just simply use these square brackets and you type in DLL import, and now you just refer to the path. Okay, use this character in order to be able to put in a simple path. If you don't use this character, the path, you will have to use double slash or backslash or what it is in the path name. Okay, so use it. I just copy the path. If you weren't using this, you would have to type it like that. Okay, and here are some auxiliary arguments. Where you can see that it's also possible to define the calling convention, but we can omit this and use our std call. Okay, and so this somehow defines the import of this DLL, and we will refer to function square. We have to type in public static extern double square and the argument double x. Okay, here you don't need to specify by value or by reference. You just use it like me. Okay, let's test the DLL file. Double result is equal to square 10. you can see that the result is correct. Okay. What I really hate on this Visual Studio is that the debug buttons are somewhere, I don't know where. So I'll have to investigate these buttons. It's here. It's actually the most used function, and it's for no reason it's hidden right here. So let me just interrupt the debug. Okay, so you can really see that this setup works, and if you use this std call, it allows you to use your DLL within C# and also in VBA, so it's compatible in both languages. Okay. The last thing I wanted to show you today is slightly different from what I was talking about up to now, and it's about some speed optimization. Okay, so let me write a function now I'm going to run the function just in C++, so there is no need for export. Double say tough loop and no number of iterations, and this is just a very stupid function which will be designed so that it's just computationally intensive. Okay, so return 0, and what I'm going to write here is a quadratic loop, which is very tough to compute. Integer I is equal to 1, I is less or equal to number of iterations, do I++, and also I can use the brackets right like that, but it's not necessary. If you use just one line of code, you don't need to use the brackets. And the second loop will be j, 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 and let's create some output arguments. Result. Okay, and result will be something very simple, I plus j. Okay, so what this code actually does, now I can, for clarity, I can use the brackets so that it is absolutely clear what the function does. So it steps right in and it iterates the same amount of cycles, and eventually it assigns value of I plus j into result. Okay, so it's nonsense, but it's just computationally intensive. Okay, and let's output result. Okay, what it returns at the very end, it just returns twice number of iterations. Okay, because it sums up number of iterations from I, and number of iterations from j. Okay, let's test the function. Double tough loop and test it with number 10. Boom. So it shall return 20. We are still in the DLL mode. So let me just switch to exe mode so that we can debug. That's probably because we have the definition file. Okay, now it works, and it will just simply compute the tough loop. As we expect, it returns twice number of iterations. But what happens if we put in some much larger value? Okay, say 50,000. Now you can see it takes some time. Okay, it wasn't that bad, but anyways, the speed is not that great. Okay, if you want it to run this function within VBA, is dramatically slower if you use just VBA's engine. So let's create the same function, sub what's it called, tough loop, number of iterations, number of iterations as long, number of iterations is equal to use less, say 30,000. Anyways, it will take ages to compute. And for nim I as long, nim j as long, result as double, and now we are entering the loop for I is equal to 1 to number of iterations next I for j do the same, and result is I plus j. Okay, so if we run it now, it will take some time. You can see, even though the number of iterations is even lower than what we used in C++, it takes a very long time. Okay, it's just because VBA is dramatically slower than C++. Okay, I'm not going to put in 50,000 of iterations because this would be very long computation. But what I wanted to show you in C++ is that even this speed is not the ultimate that you can punch out C++. Okay, it can be even faster than this. Okay, so now there are several steps what you have to do in order to speed up your computations. The computations involve some speed up setting in C++ optimization and use maximize speed. If you wanted to run the application now, it won't work. Okay, you have to disable some other features. I don't know exactly where these are hidden. You have to ZI. Okay, ZI must go away, and you can use C7 compatible. We can try it. It still doesn't run. So go to properties, and here you're gonna have to use default. Okay, and now it shall work. Okay, and you can really see that it's already computed. Okay, it doesn't really respect the breakpoint because we have disabled some debug features, but you can really see that if I run it, that's all, it's already computed. And you can, even with this disabled debug features, you can run it easily from VBA or C#. We can export the function so that you can see it. Std call tough loop, and we have to edit into the export list. We have to activate again the definition file. Def here, and I forgot to do one more thing to change it from application to library. Okay, now it should work. And so if we add a function called tough loop, and we are not sending a double, but we are sending integer. But notice that integer in C++ is the same as long in VBA, so as long, and it returns double. Okay, so one more thing, tough loop VBA, rename it like this. X as long, number of iterations as long, and the output is as double, and here it returns okay. I hope I haven't made any mistake, and let's see how this VBA function performs against the C++ function. Okay, so number of loops or iterations, say 30,000, and result VBA result C++, tough loop VBA and now the computation has started. Okay, now it's computing. So you can see that it really takes some time. Okay, now I just disable this function so that it doesn't activate while we are computing it using the C++ function, and tough loop, and that's it. Okay, so basically the same computations are much more faster in highly optimized C++ than VBA. If you use the unoptimized C++, it would take much more time. We can test it. So again, disable the optimization features. Disable the optimization, use this one again, and the last one. Okay, basic runtime checks. Okay, save it. Oh, what a mishap. Okay. So the function isn't really here, but doesn't matter, we'll write it again. We just built this DLL file again. Okay. We have no offer of the previous function. That sucks. I haven't saved it. But anyways, let's just call the function for imagination by val number of iterations as long, and the function name is tough group. Okay. And you can see it will take substantially longer time than what we have seen before on the highly optimized function. Okay, so you can see the best speed is C++ optimization enabled. This is the fastest possible computation. Second, C++ optimization disabled. And the last one is VBA. So this just simply demonstrate how powerful C++ is, especially for difficult computations, and that it is definitely worth to let these computations perform in C++ rather than VBA, because VBA is just a face that can interact, that can somehow interact with C++, but it isn't really good for difficult computations. Okay, so I hope you have enjoyed my video, and subscribe for my channel, and well, I'll try to come up with some new interesting video that you can use.